Okay, so this problem states that we have potassium superoxide reacting with water to form potassium hydroxide and oxygen gas, and they give us a balanced chemical equation. And we're told that we have 125 grams of the potassium superoxide and 45 grams of water. First thing that we're asked to solve for is the mass of oxygen that can be produced. Now in the past, they've only given us a mass of one reactant. For this problem, you notice that they give us masses for both reactants in the equation. So you have to know that this means that that is a limiting reactant problem, and we have to solve it a little bit differently. Okay. So a limiting reactant, what we're going to do is we're going to take this 125 grams of the potassium superoxide, do a stoichiometry problem to find out how much oxygen we could make. And that's going to assume that I have enough water to react with it. Then we're going to do a second problem where we take 45 grams of the water, assuming that there's enough potassium superoxide to react with that water, and find out how much oxygen we can make. That way we can then identify which of these two reactants is my limiting reactant. So starting with the first problem, I have 125 grams of the potassium superoxide. I need to get to moles so that I can relate the 4 moles of the potassium superoxide with the 3 moles of the oxygen in a mole-to-mole ratio. So getting to moles, I'm going to just use the molar mass of the potassium superoxide. Then I can relate the moles of the potassium superoxide to the moles of O2, and that is just 4 to 3 from the balanced chemical equation. Then we can find out how many grams of oxygen that would make. Calculating a molar mass for the potassium superoxide, I get 71.1. So my calculator, I would do 125 divided by 71.1 times 3 divided by 4 and then times 32. Excuse me. So I have that I will get 42.194 grams of oxygen. I'm not rounding to a final answer yet, and I may have to use this as an intermediate, so I'm going to copy more significant figures than I need. So this is the amount of oxygen that can be made if I have an excess of water for my 125 grams of potassium superoxide. Now I have to do the problem where I have 45 grams of water and as much potassium superoxide as needs to react with it. First thing I need to do is get the water to moles so that I can use a mole ratio and that balanced chemical equation to get to the moles of oxygen. That mole ratio is 2 moles of water for every 3 moles of oxygen. And then again convert those moles of oxygen to the mass of oxygen. Okay, so filling in everything, 45 divided by 18.02 times 3 divided by 2 times 32 gives me 119.87 grams of oxygen produced. So looking at these two, this is the least amount of oxygen, so my limiting reactant, let me get a different color. Orange is good. So my limiting reactant is my potassium superoxide, and the mass of O2 produced is 42.2 grams of O2, rounding to 3 significant figures. Okay. So moving on to the second part of the problem, which is going to ask us hang on a sec. Okay, the second part of the problem asks what, oops, I have to get a pen, sorry. What mass of excess reactant is left over? So going back to our problem, our excess reactant is the water, and we know that we're going to make 42.194 grams of oxygen. So we know we made 42.194 grams of oxygen, and we had 45 grams of water. Okay. Let's calculate the mass of water used to make 42.194 grams of oxygen. So I have 42.194 grams of O2 times 32.00 grams O2 in 1 mole of O2. Now I want to convert moles of O2 to moles of water. Looking back at the balanced chemical equation, 3 moles of oxygen for every 2 moles of water. So it's 3 to 2. And in 1 mole of water, I have 18.02 grams. So this gives me multiplying 42.194 divided by 32 times 2 divided by 3 times 18.02, I get 15.84 grams of water used. But the problem asks me how much is left over. Well, so mass of H2O left over is going to be the original mass minus the amount used, which is going to be 45 grams of H2O minus the 15.84 grams of H2O used, which will be 29.16 grams of water. Rounding for sig figs, 29 grams of water is left over. Okay, that concludes the example limiting reactant. Have a great day.